Okay, here is an example. In this example, he's asking for finding the z parameters. Okay, so the z parameters are nothing but z11, z12, z21, z22. Okay, so this is the given circuit. So step one, you always take this as V1, and remember, always current is going in. The second current I2 is also going in, and this is V2. V1, V2, I1, and I2. Label those four. Okay, so basically, if you look into the previous video, if you saw it, you always have a block box. So here, instead of block box, you have this element, these elements like resistors. I don't have any other elements in the circuit, but probably next example I have different elements. So we always take this as I1, V1, I2, V2. Why am I choosing I2 going towards in? Even though these are input terminals, V1, I1, those are the input, this is the input port, or these are the input terminals. This is the output port or output terminals. So I2 must be going out. But for convenience to find the impedance parameters, we always take I2 going in. For sure, at the end, you will end up with I2 as a negative number. But our goal is not finding I2 or V2. Our goal is finding these parameters. What are the Z parameters? How is it helpful? I'll talk about it at the end of this example. Now, our next step is write down the two equations we use to find the impedance parameters. If you remember, V1 equal to Z11 I1 plus Z12 I2, and V2 equal to Z21 I1 plus Z22 I2. Our goal is finding this Z11. As long as you remember these two equations, you don't need to remember Z11, Z12, all these things. You can derive from these Z11, Z12 from these equations. So Z11, what is Z11? This parameter must be 0, so I2 must be 0. So Z11 equal to V1 over I1 when I2 equal to 0. Now, so I'm going to draw the circuit. The given circuit is, here is the given circuit. Here I have only 3 elements. It's a very simple example, but when you go to the real world, for sure you will end up having hundreds of elements like this. So there is another way of solving those big examples. We are trying to find how to find the input impedance. So when we look at the terminals from these two terminal point of view, what is the impedance from these two terminals? I'm assuming this current equal to 0. Since I'm assuming I2 equal to 0, is this element is going to affect us anywhere? No, because there is no current passing through this, so there is no voltage drop across this. Okay, so here is my V1 and here is my I1. Okay, so can I write the loop equation? Write loop equation. So if I write the loop equation, that's 2 ohm, that's 6 ohm. So applying loop equation is nothing but KVL. If I apply KVL, V1 equal to 2I1 plus 6I1. So it's going to be 8I1. I can write V1 over I1 equal to 8, which is V over I, which is nothing but Z11. Z11 equal to 8 ohms. As I mentioned, it's a very simple example. So down the line, I will solve little more difficult examples. Now, I can use the same circuit to find Z21. So after finding Z11, instead of going to Z12, I'll find Z21. So we'll use different color. So I'm going to find Z21, which is nothing but V2 over I1. So as I mentioned, I'm going to use the same circuit. What is V2? Still, V2 is right there. Okay, V2 is right here, and I know the voltage drop across this is 0 volts because there is no current passing through this. So can I say V2 is nothing but voltage drop across 6 ohm? V2 equal to voltage drop across 6 ohm since there is no current passing. There is no current passing through 4 ohm. Resistor. So V2 is voltage drop across. So can I write my, I2 equal to 0 in this case. So V2 equal to apply KVL, or I don't need to apply KVL, but from the equation, can I say my V2 equal to 6 times I1? Okay, because I know the current passing through this element is nothing but I1. The current is coming in that direction. So V2 over I1, can I write this as Z12 equal to V2 over I1, where that is going to be 6 ohm. That is our second parameter. Okay, so I found Z11, Z21, and I'm going to find next two parameters. So we found two parameters. These two parameters, I'm going to find this is the last two parameters. So I'm going to find Z12, which is nothing but V1 over I2 when I1 equal to 0, and Z22 is nothing but V2 over I2 when I1 equal to 0. So it's the same circuit. I'm not changing any circuit elements. Okay, so this is my V1, here is my I1, here is my I2 and V2. I'm going to find Z22 first because it's easy, and then I can come back for Z12. So what are the parameters I have? I have 2, 6, 4. So here is 2 ohm, 6 ohm, 4 ohm. Okay, now I'm going to say apply to find. So I'm going to find Z22. Okay, find Z22 first. It's easy to find Z22, so that's the reason I am recommending you to find Z22 first. So apply to find Z22, apply KVL in the loop. Apply KVL in the loop from V2 point of view. So I'm going to apply KVL here. Apply KVL here. I'm assuming this is I2. I know this current is 0, so the voltage drop here equal to 0. So the V1 must be right there. So if I apply KVL and V2, loop 2, V2 equal to, or I can say apply KVL and loop 2. That's the easy way to do it. 4I2 plus 6I2, which is 10I2. Okay. So what is V2 over I2? This is Z22, which is 10 ohm in this case. Okay, that's my Z22. Now what is Z12? Z12 equal to same thing. It is nothing but V1 over I2. So if you look at here, I can look into the circuit. I can say V1 equal to 6 times I2. So 6 times of I2, it's going to be 6 ohm. Okay, now in this circuit, as long as Z12, so in this circuit I have Z12 and Z21, both have 6 ohm. So as long as Z12 equal to Z21, we can represent the given circuit into a pi model. So as I mentioned in the starting, we don't know what is there in the black block box. So all I know, that's I1, this is V1, I2 and V2. Now by using these parameters, I can represent the inside parameters by using a T model. So T model is nothing but it's look like a T, so that's the reason we call it as T model. So to write down the T model, here is the parameters I'm going to have. So this is inside the block box. Okay, so this parameter is going to be z11 minus z12. This is z12. This is going to be z22 minus z12. Okay, so this is the inside the block box. So still I have I1, V1 and V2 and I2. So if you substitute these values, if you remember, I have z11 equal to 8, where is that, z11 I have 8 ohms and z21 6 ohms. So here 8 minus 6, so that is 2 ohm, and z22 minus z12, which is 10 minus 6, this is 4 ohm. This is 10 minus 6, 4 ohm, and z12 is 6 ohm. So I mean the given circuit, actually I gave you the same circuit, 2 ohm, 6 ohm, 4 ohm. Okay, I mean you can clearly see that's look like a T model, but some examples might have more than 3 elements and they might be connected in series, parallel, or star, delta. We don't know which which connection it is. Still we can represent them in this T model as long as z12 equal to z21. So as long as that's a reciprocal network or reciprocal network. Now we can convert this T model into a pi model. So T look like this, right? Okay, and the pi model look like this. This is the T model or T network, and this is pi network. Okay, so how to convert T network to pi network? It's just if you look into this, it's just look like a T network, look like a Y, and the pi network is going to look like a delta. Okay, so what I'm going to do, this is going to be look like Y and delta, so similar to converting Y to delta. So here I have a 2 ohm, 6 ohm and 4 ohm, right? So I'm going to label them A, B, C. Okay, so here this is RA, RB, RC. Resistance connected to A is RA, resistance connected to B is RB, resistance connected to C is RC. Now I'm converting this into a pi. So when I convert this into a pi, it's going to be look like this. This is R, let me label them as RCA. Okay, here is RAB. Here is RBC. Okay, now to find RAB equal to, what I'm doing, I'm converting a T network into pi network. Why am I doing it? I'm representing as long as the given circuit or given network is a reciprocal network. Reciprocal is nothing but z12 equals z21. I can convert that into I can represent the given circuit into T model. So this is how I wrote down the T model. Now I'm converting T model into pi model. It's just for convenience purpose. Sometimes T model is easy to find, easy to solve. Sometimes pi model is easy to solve. So here my RAB equal to RA plus RB plus RARB over RC. Okay, remember always RAB is larger than RA. Okay, so 2 plus 4 plus 2 times 4 over 6. Okay, so this is going to be 6 plus 8 by 6. That equal to 1.33. So 6 plus 1.33. So that is 7.33 ohm. That's RAB. Now RBC equal to RB times RB plus RC. So add these two plus multiply those two divided by the remaining RA. So I have 4 plus 6 plus 4 times 6 by 2, which is 10 plus 12, that is 24 ohm. Sorry, 22 ohm. That is 22 ohm. Now RCA equal to RC plus RA plus RC times RA over RB. I have RC equal to 6 plus RA equal to 2 plus 6 times 2 over 4, which is 8 plus 3, that is 11 ohm. So now my equivalent circuit, so I have a T model, something like this. This is RA, RB, RC. This is I believe 6 ohm, 4 ohm, 2 ohm. Now when I convert this into pi model, it's going to be look like this. Make sure that you represent or put them in the same order. So this is RAB, this is RBC, this is RCA. So I have RAB equal to 7.33 ohms and RBC equal to 22 ohms and RCA equal to 11 ohm. So still my circuit, my network is going to be, this is V1, I1, this is I2 and V2. Okay, so as long as a circuit is a reciprocal circuit, a reciprocal network, I can represent them by using T model. This is the T model. Now once I know the T model, I can represent them into or convert them into pi model. Thank you.